So, what I am going to do today is I am going to talk about just start talking about the history of AI. So, in terms of the introduction, we will first talk about the history of AI, the present of AI, why is there so much interest in AI. Then we will start asking the question, what is AI, right. AI as a phenomenon is actually a very complicated question, a lot of people disagree on what is AI. So, we will try to have our best definition possible and some recurrent themes in the field of AI. So, this would be our introduction, then we will start talking about the technical content. So, the initial first few lectures are going to be just introducing the subject for you. And let us start from one of the salient events way back in 1940s, where an ENIAC computer was constructed, designed, developed. Now, ENIAC stands for Electronic Numerical Integrator and Computer. Okay. It is the first electronic general purpose computer, and it was Turing complete. Turing complete, if for people who are advanced enough, there is a Turing machine which is a mathematical model, and technically with a fixed amount of tape, the whatever Turing machine can do, ENIAC can do too. And it was capable of being reprogrammed to solve a large class of numerical problems at the time. Now, let us go back to the 40s. By the way, this is one computer, just so you know, and it is not, it is much worse than the computers you and I have on our phones. So, of course, we know this, right. What would I use the computer for if I am in the 40s and I suddenly have something that can do computations? War supply logistics, that is a good suggestion. You require probably more algorithmics to be developed before you can do logistics, but that is a reasonable suggestion. Yes? Code breaking. Yeah, code breaking, I think Alan Turing was trying some code breaking at the time. I do not know, I do not think ENIAC itself was used for code breaking. Anybody else? So, it was designed to compute artillery firing tables for the United States Army, but you both had the right intuition in mind. It was being used for defense purposes. By the way, this is not just the 40s. I will claim that a lot of progress in AI has happened because of defense and wars and enemies. This is not, I mean, we can smile about it, but which in every country, have you seen a country which puts in more money for science and less money for defense? At least some of the countries which have more money, like significant amount of money. We all know US government policies. I mean, they of course put a lot of money for science, but they usually put money for science for defense or engineering for defense. Right from the very beginning, AI has been heavily funded by defense agencies. And of course, we are talking 40s, World War has just happened, and obviously defense is on minds of everybody. So, they would use the this computer for artillery firing tables, and it was said at the time that it could do things, it could compute a trajectory of a projectile in 30 seconds, where a human computer, and by the way, we do not hear about the word human computer now. Have you heard this word human computer? You have? There was a time when there was a job called human computer. There is a beautiful movie about NASA and 3 women. Does somebody remember the name of the movie? Nobody remembers? I am sure somebody has seen it. It is about 3 African American women who are employed in NASA as human computers, or at least as some form of computer. So, basically their job was, and we will find the name, if somebody remembers or can Google it, let me know. So, their job was to do computation, and they would compute these projectiles, and they may take about 10 hours to compute one projectile trajectory. And this thing can do, the ENIAC could do the same thing in 30 seconds, right. So, notice that right from there, and of course, now human computers is not a job, not surprising, right. There is also a beautiful story about a woman who really got a bunch of these women together and they trained them as human computers in a time where these women did not have much to eat and so on. That is a different beautiful book, but anyway. So, that was then, right. And now that this was the time when computers were coming into the fore, right, it was a reality, not just a figment of somebody's imagination. They did not ask the question, can I use computers for word processing or can I use computers for Excel like spreadsheet management or maintaining my database. In 1950, Alan Turing, who is considered the father of computer science, you all know about Alan Turing, right? Some of you may have seen The Imitation Game, yeah. You must see that movie, beautiful movie. He said in his seminal paper that I propose to consider the question, can machines think? Now, that is why we call him the father, because that particular question that he asked in 1950, when this one big computer or some of these computers have just started coming out and the only thing they are doing is computing the trajectory of projectiles and so on and so forth. He is starting to think as far into the future as possible and being somewhat of a luminary and writing these seminal papers thinking about these philosophical questions. And he asked the question that, okay, let us say a machine can think. How would I know that it thinks? Now think about this question for a minute. Suppose I claim that this podium, which is made of wood, thinks, has the ability to think. Without casting any judgment on what wood is made of and what is wood and whether we have any prior on whether this is living or not living, let us not worry about this. Let us say I make this claim that this podium thinks. How would you and I even assess whether this podium thinks or not? Now, let us take another example. Whenever we ask such philosophical questions in AI, we relate them back to our life. Suppose I have to ask the question, does my friend think? What would I do? I would ask them a question. I would ask them a question which I think my friend should give a correct answer for if I want to believe that this person really thinks. Right? This is a good question, it is an intelligent question. If I ask an intelligent question and my friend is able to give me an answer, then I would make the claim that this my friend thinks. Suppose my friend could not speak. What would you do? Written answer. Suppose my friend did not have any hands. Sorry? Another person could write for them. How? They can't speak, they don't have hands. Create a situation where they have to make a decision, and decision would be seen by some movement of hand, blinking of eye, movement of arm, moving of legs, whatever, right. Suppose they did not even have an ear and an eye. Now, I know we do not want to visualize such a person, and it is becoming very gloomy at this point. But think of it as a thought experiment. This is probably what Alan Turing also thought about at the time. I do not know, hopefully. Suppose I have a person who cannot see, who cannot observe the environment, who cannot make a difference to the environment. So, does not have hands, does not have voice, does not have eyes to blink, does not have any motors, has a brain inside. Is it possible that this person still thinks, but we will have no idea about it? Is it possible? Come on, at least nod one way or the other. Yes, it is quite possible that, and you may have seen, and sometimes I met a person, who had Parkinson's disease, but the Parkinson's disease had, gone to a certain extent that there was full paralysis, and so the person was not able to communicate very much. And we did not know very well whether the person is able to observe the discussion or not, whether the person is able to understand what is going on around their surroundings or not. This is even possible in a human in today's world. It is possible that their brain was working perfectly, they just had no way to communicate. It is possible that their brain was not working at all and we just have no idea. So, the point is, not working at all means not working in terms of the what understanding perception of the environment. So, the point that Alan Turing came back with is that it is possible that this podium thinks we have no way to know, because the podium has no way to communicate with us. So, you will over time see that communication with the world by listening, producing an output, not listening by ear necessarily, by observing or by looking at the environment, perceiving the environment, and then producing an output, is critically important for us to judge whether there is an AI system sitting in there or not. Okay? Because the brain is meaningless in absence of the communicators in the body, right. And therefore, he said that the only way we can figure out that a machine thinks is by asking it questions or creating a scenario where we can judge its decisions. And he devised the very famous Turing test, right. I am happy many of you know about it. It has become part of a folklore of AI and folklore of computer science, and we will talk more about it at the time a little later. But he said that the Turing test would be a good test to figure out whether machine thinks or not. Notice by that time the field of AI is still not born. This is still his thought experiment, and he has written this paper. Now, of course, this idea starts to pick up. And in 1956, 4 of these people come together to do a 2-month workshop at the Dartmouth College in 1956. These 4 people are called the founding fathers of artificial intelligence. They say in their project proposal, we propose a 2-month 10-man study of artificial intelligence. So, this is the first time the word artificial intelligence starts to get used, and it was given by the very first person on the right, John McCarthy. Now, John was at Stanford. He worked a lot on chess, and he also created or co-created the language called Lisp, which is a declarative programming language which became very popular in the 70s and 60s. They say that in 2 months we will solve artificial intelligence, and they meet together at Dartmouth College over the summer, and that is where the field was officially born. Of course, they had to spend more than 2 months for AI to be solved, and we have still not solved it, right. So, therefore, there is one thing that I feel when I think about most AI researchers is that they are highly optimists, they are heavy optimists. They feel that we can do something much before anybody in the world is ready to achieve it. And they of course fail, but that is okay, they move the field forward. And these were the 4 optimists who thought that they can solve most of AI in 2 months. This joke, but that is somewhat true also. Let us talk about the other 3 people. Alan Newell and Herbert Simon are in the middle. They were from CMU. They were working on logic theorists. They were trying to figure out, can we somehow create a theory of how to prove theorems? Can we create an AI system which will be able to prove theorems automatically? And lastly, at the bottom there is Marvin Minsky from MIT, who has many contributions, including he built one of the first neural network learning machine. And he is my great grandfather, at least academic grandfather. So, my advisor is Marvin Minsky, right. And he was the person who started the MIT AI laboratory. So, at the time these 4 people from Stanford, CMU and MIT came together and officially started the field. So, now what happened initially? Of course, there was enthusiasm, people were coming together and trying to solve these problems. So, if you look at the history, I mean there are many things going on, but at the highest level Turing test came in 50s, AI itself was born in 56. In 64, so by the way language and language communication and all that also was part of AI, and ELIZA was the first chatbot way back in 1964 by the way. We live in a world where chatbots have become extremely important. We all have chatbots to play with and spend time with, kill time with and so on. The first chatbot was in 1964, and believe it or not, and it is a funny story, where somebody on their private messaging system, instead of having your own response, put ELIZA in. And one person started communicating with ELIZA and ELIZA started asking personal questions, and this person started answering personal questions. and this person felt like there was a real psychotherapist sitting on the other side. When you come to my NLP class, we will talk more about ELIZA and how to make chatbots, not in this course. But this happened way back in the 60s. The first general purpose mobile robot, and you can see a picture on the right, is Shaky. You should Google Shaky, you should learn about it and so on. Shaky was an amazing project. This was this robot which had many sensors and so on. It had a camera control unit, it had a television camera, it had a range finder, it had wheels and so on. And at that time, people in Stanford were using Shaky as a platform to do interesting AI. And I remember in 2016, there was a 50-year celebration of Shaky at a AAAI conference. And a lot of the people who worked on Shaky at the time, who were still alive, they came together and started narrating very funny stories about Shaky and so on. It was really amazing to hear, 50 years down the line, Shaky was still relevant, because in that process, they developed one of the most important algorithms of AI called the A-star algorithm. And we will talk about A-star algorithm in hopefully week 3. You will see that what happened 50 years ago, 52 years, 53 years ago was still extremely important and being used in many places, including possibly your assignment 1. Then things started to go bad. They started to go down south. And since we are in the US, summer is a great word, spring is a great word, but winter is a bad word. So you should think of AI winter, not from an Indian point of view where you are like, wow, we have winters now. You should think of it from the US point of view where, oh damn, we have winters now. It is going to snow, it is going to be negative minus 20 degrees Celsius or whatnot. I can't go out, my eyebrows are going to freeze, and so on and so forth, right? You have seen those videos where you put water in the air and the water freezes mid. We are talking about winters. And they were winters, and they were not one, but there were 2 AI winters that came over time. In 1974 to 80, there was one winter where people who were working in language started to feel that, oh man, this is not working out. There was one seminal report which said machine translation is very hard, it's not going to succeed. A lot of funding in machine translation at the time came from defense agencies. Can you guess which languages did they care for at the time? English, Russian. We are in the Cold War time. So of course, all the effort was going into making sure that we can understand any things that we can intercept in Russian language, right? And they said that, oh man, machine translation is very hard. Neural network had come in, but Marvin Minsky wrote a paper saying that neural network is very hard. It can't even do XOR function. You know XOR function from your logic, I hope. And similarly, there was a report, there was some frustration on speech understanding. They were able to show that if you speak words in a certain order, you are able to parse it and understand it, but otherwise the system can't do anything. And by the way, all these problems remained unsolved or mostly unsolved until very recently. And they are still not completely solved, but we have made substantial progress in the last week. So because of all this, suddenly we were in a place where there was so much excitement about AI earlier, and then it died down. Then it started coming back up, and Lisp was working. There was something called the expert systems era. And even now, some people who are still stuck in the 90s who teach the old style AI course, they will teach expert systems. We don't talk about expert systems in this course anymore, because this is a thing from the past. But the idea of expert system was somebody uses a logical language to encode all knowledge about their field. Like if you want to make an automated doctor, you will say that this disease causes these symptoms, this disease can be treated by this medicine, etc., etc., etc. So you put everything in a logical framework, and then given the symptoms, you do some inference to figure out what disease you may have, what treatment should be given to you. That was an expert system. And at the time, they started making specialized hardware for expert system, and it became a $500 million industry. But within a year, all that $500 million industry was wiped out, because new machines came out which were much better, and they were general purpose and so on and so forth, and all this industry died out. But more importantly, what died out, the reason why AI went through these winters is because AI researchers were die-hard optimists. not cautious optimists or realists. They started saying from the very beginning, we are going to solve intelligence. We will make a machine that will be more intelligent than you. We will defeat you in chess. We will solve theorems. We will communicate in language. We will understand your speech. We will do machine translation. They kept making all these claims again and again and again and again and again. And of course, defense agencies who know nothing, they said, oh, we'll give you $1 million. We will give you $2 million. What happened? What came out? What came out? Nothing. I wouldn't say all the money down the drain, but from the perspective of a person who wants to use the technology, they will feel that the money is down the drain because nothing substantial which is workable has come out. So AI started getting bad name to the extent that people thought that, oh, AI folks, these are, acha. The other thing you have to realize is that they were also computer scientists, theoreticians mostly, who really cared about proving things. They were like, give me a problem, I will figure out its complexity class, give me a problem, I will create an algorithm and prove things about it. On the other hand, these AI folks were interested in working demonstrations. They will prove, but they were interested in working demonstrations more than the proofs, because of which the computer scientists, theoretical computer scientists will say, you guys are not formal enough, you guys are not mathematically rigorous enough. On the other hand, the applications people will say, you guys don't, your guys' solutions don't work. So they were sandwiched in the middle. Neither the applications people are happy that you can achieve anything that works, nor the theoreticians are happy where you can achieve something you can prove anything about. So even in the computer science world, AI started getting bad name. It started being looked at as set of people who have these heuristic techniques which sometimes work but have no theoretical basis. So therefore, I remember, and by the way, some people remain stuck in time, right? For example, after being in IIT for 4 years, if you go home, your mom will still think you are a 17-year-old. She wouldn't know that you are 21 now, and you have moved on and you have become a different person. I remember a beautiful talk by Shyam Benegal, who said that my mom still thinks I am 14-year-old. I'm not kidding you, he said that explicitly. We remain stuck in time. You go to look at your friends who are in the US now. Their notion of India is the notion that was when they left India. So if you go talk to uncles and aunties who left India 30 years ago, their notion of India no longer matches with any notion of India today. But they are stuck in time. So we are always stuck in time. So there were people, even in this department and in India in general, who were stuck in time. They thought that AI hasn't moved because they did their PhD in the 90s. That is where AI was not a very good word. AI became a bad word actually. In fact, there were people who cut their cords from AI. There were topics which were part of AI and they created their own sub-communities and started saying, we are not AI, we are computer vision. We are not AI, we are natural language processing. We are not AI, we are machine learning. And I lived through that time, therefore I can relate to it. I remember that in 2000s when I was doing my PhD, AAAI, there were 5 communities which will still say we are part of AAAI. 5 is just a number, 3, 4, 7, something like that. And there were many such communities which will only go to their local conferences and will never come back to AI conference. Because they thought AI is a bad word, let's stay away from it. Let's say we are whatever we are. So when I would come back to IIT Delhi, I was a student here, undergrad. When I came back as I was still doing PhD at the time, I told some of my professors, not ex, they are professors now, my colleagues today, that I am doing AI. They will say, oh, you are doing AI, okay. They will give me this sheepish smile. I don't know why they are giving me a smile. But it was clear that it's not a smile of appreciation. And then I have one person who I would not name, who always speaks his mind, thankfully. So he said, okay, you are doing AI, what are you doing in AI? So I told him, oh, I am working on this Markov decision process model. Oh, so say you are doing operations research, why do you say you are doing AI? Now, for people who don't know, MDPs as a model came from operations research in the 50s, but over time it got adopted by AI and it's something we will study later in the course. So, I was very confused what is going on, and then it dawned on me that to them AI is still the AI of the 80s and 90s when we were having AI winter and AI had become a bad word. So, this had lasting effects because, and this is at Economist 2007 note which says AI is associated with systems that have all too often failed to live up to their promises. And in this world, over time AI has now come out, and we will talk about the present in the next class. But this graphic shows you the number of attendees for several AI conferences, and at the 80s it was only IIII and ICHKI if you see, and there were almost 5,000 attendees. If you see here, there were almost 5,000 attendees at ICHKI conference in 1985. And it went down so rapidly that over time it was less than 2000, there may be 1500 people started coming. I remember a time when IIII had less than 1000 attendees, and we were very worried that we will maybe even have to close the conference, or we can't fund it anymore. From there, we have now reached a point where all conferences are starting to see a jump in their attendees. And of course, the conference that has won the most in this is NeurIPS or NIPS. NIPS is the old name, now it is NeurIPS, right, Neural Information Processing Systems. And notice that this is not even the current figure. So, I remember that for NIPS, 1 year there were 2000 attendees, next year there were 4000 attendees, and next year there were 8000 attendees, to the point that the year after that the general registration closed down in less than 12 minutes. Now, think about World Cup cricket tickets. Even for an India-Pakistan match, you will probably get more than 12 minutes to buy the tickets. This is NeurIPS technical conference we are talking about. Believe it or not. If you really want to go to NeurIPS, you have to buy it in the first minute of the registration opening, or you should have a paper in there. So, those are the two possibilities. So, AI, it is said that Yann LeCun is a celebrity in China. Yann LeCun wrote on his Facebook page that he was walking in the streets of China and random people started coming to him and started saying, "Oh, you are Professor Yann LeCun, so nice to meet you," or things like that. You know, this only happens to people like Shah Rukh Khan and Vidya Balan now in India. I have never felt that. I feel so sad about it. Someday. And this is before Yann LeCun won the Turing Award, I want to say, right.